Hello everyone, welcome to the BDM channel, Motor Sizing Special Series. I'm your instructor, Bill. This Motor Sizing Special Series is a new program started by Instructor Bill. In this series, we will cover 28 lessons, from common motor types in non-standard automation, to the methods for matching inertia ratios under various motor drive conditions. This is the content I will explain in detail for you one by one. As we all know, motors, as power components, are widely used in non-standard automation. Whether you work in 3C, lithium battery, medical, pharmaceutical, automotive, conveying, or industrial robotics, motors are used across different industries, operating conditions, and structures. The selection criteria and types of motors used vary. Isn't it true that during the selection process, the design process, we need to know all this relevant knowledge? This series will explain it to you step by step. Today, let's look at the common motor types in non-standard automation equipment. You can see from the category on the left. In this equipment drawing, this is an industrial robot. Industrial robots use servo motors, right? Okay, well then, in other industry equipment, like belt conveyors, right? Belt conveyors. These conveyor lines use geared motors. How do we distinguish between these motor types? How do we design them into different structures to carry out the structural design? Well, at this point, we need to classify them. Usually there is a broad classification. Let me show you the broad classification. Take a look. I categorize motor types into three main classes. These three classes are standard motors, control motors, and direct drive motors. So, how are these three categories defined? Those used purely for power are called standard motors. They only provide power. The second type provides power and can also achieve speed control, position control, and torque control. We call these control motors. Of course, not all control motors can achieve all three control modes. We'll talk about that more in a moment, okay? Okay, the third type is direct drive motors. As you can see, direct drive motors allow the motor to connect directly to the load without needing couplings, chain drives, or belt drives for transmission. So, the third category is direct drive motors, used for high-precision applications. The common types of standard motors. Standard motors include, as you can see, in various conveyor lines, they mostly use standard motors. There are three-phase AC induction motors, single-phase motors, geared motors, variable frequency motors, and speed control motors. Three-phase and single-phase motors are relatively different. One uses three-phase power, the other single-phase. Three-phase AC induction motors must use three-phase power. Using single-phase power will burn out the motor. Single-phase motors to reduce power supply demands. Typically, like many household appliances, use single-phase power. Therefore, for some small conveyors, we often use single-phase motors for control. So, this way, control is relatively simpler, but single-phase motors are generally for low power. Three-phase motors can be used up to 2,500 kilowatts. Geared motors are used to reduce the speed of three-phase or single-phase motors, which are often too fast to match the required operating speed for the application. So we add a gearbox in front of the motor. Thus, a motor with an integrated gearbox is called a geared motor. It can reduce speed and increase torque. That's its characteristic. So, in many cases, whether it's heavy-duty belt conveyors, roller conveyors, slat conveyors, or belt conveyors, many slightly larger conveyors use this type of geared motor because its output torque is relatively large. Now, the last two motor types allow for speed control. One is the variable frequency motor. The other is the speed control motor. Variable frequency motors can handle larger loads. Speed control motors are generally for small belt conveyors. You can see, for example, in our small belt conveyor lines. Typically, speed control motors are used. They are usually matched with a speed controller. The speed controller allows multi-step or three-step speed adjustment. You should know, typically, for example, in 3C industry, or lithium battery small conveyor lines, like our synchronous belt conveyors, or these belt conveyor lines, and narrow edge conveyor lines, some will use such speed control motors. This is important to note. It uses a manual speed controller for adjustment, not for stepless speed control. Well, when we need stepless speed control, position control, and torque control, we need to use control motors. There are two types of control motors. One is stepper motors. The other is servo motors. There's also a middle type, closed loop, steppers. A stepper is an open loop control motor. Generally, it can achieve speed and position control. So, it's important to note they are generally used for light load applications. For example, like our desktop screw-driving machines. Desktop screw-driving machines often use them. Well, relatively speaking. In our design applications, we might also use a type that can achieve closed-loop control, like this closed-loop stepper. Now, the closed-loop stepper has an encoder added to the back of the motor. After adding the encoder, it can achieve closed-loop control, but it cannot completely replace servo motors. And it can only, to a certain extent, be used as a substitute. For example, for our servo, in such a screw-driving machine, we usually use Leadshine's 57 series stepper motors. But sometimes, when we need to make vertical type, high-precision screw-driving or dispensing machines, what motor should we choose for the shaft? We can choose servo, or we can choose closed-loop stepper. If it exceeds 1,500 revolutions per minute, I recommend using servo motors. But for 1,500 revolutions per minute and below, we can use closed-loop steppers. So, it's important to know this. Finally, the last type is our servo motor. Now, servo motors are widely used, high-precision, closed-loop control motors. For example, when we design equipment like this industrial robot, or when making screw-driving machines. If we don't use standardized screwdriver heads, we can also use servo motors to create such a screwdriver head because it can achieve torque control. So, relatively speaking, for high load, high response speed, and high precision applications, we typically choose servo motors, this type of control motor. So, these are the three types of control motors. Okay, the last category is direct drive motors. As we know, standard motors and control motors, when connecting to the drive, must have a connection device. For example, take this linear module. Look, it must have a coupling, right? Of course, others might use timing belts or chains for such transmission. But is there a type that can directly mount the load onto the motor itself for driving? Yes, and that is our direct drive motor. Direct drive motors have three types. First, linear motors. The second type is called DD motor. The third type is voice coil motors. Let's first look at the linear motor. As you can see, this bottom part is the stator. The top part is the mover. There are guide rails on both sides. So, when we energize and control the mover, it can move back and forth, right? So, in this case, we can mount the load directly onto this plate. It can directly drive the load for movement. Now, here, I can show you an actual equipment photo. For example, this high-precision laptop. Key detection equipment. Here, its X-axis and Y-axis use linear motors. See? So, this way, with the addition of a linear encoder, it can achieve high-precision position feedback, high speed, high response, and high-precision motion. It can achieve all that. This is the application of linear motors. Of course, linear motors include flat-type linear motors and also tubular linear motors, but tubular ones are used less frequently. I will introduce these later. The second type is the DD motor. Maybe some students have seen less of it. DD motors, also called as torque motors, but unlike the torque motor type in standard motors, these are full closed loop, servo controlled. That means full closed loop control offers very high accuracy. Its advantage lies in when we need rotary indexing motion. It can achieve high precision indexing. At the same time, when we are designing, it's important to know it is superior to cam indexers because it can perform multi-point random positioning. That means, for example, in this laser marking machine, it uses a DD motor to achieve circular motion. Inside, it can achieve high precision indexing. Its high indexing accuracy is higher than that of hollow rotary platforms or indexing mechanisms made with servo motors. It's higher. So, this is important to note. For example, in some rotary and effector applications and indexing applications, they are used. The last type is our voice coil motor. Actually, here, I had a drawing prepared for you, but it didn't open. But I can tell you, voice coil motors are used for high-speed reciprocating motion. Well, we can use voice coil motors. They can also be used in high-speed vibration applications. For example, we use a common vibrating bowl feeder. Now, some flexible vibrating feeders use a voice coil motor at the base for high-speed reciprocating vibration. This achieves part flipping, reorientation, and then camera recognition, followed by picking, right? So, voice coil motors are used more in such applications when specifically designing modules or structures from scratch. It might be relatively less common, so it's good to know about them. So today, we have summarized the common motor types used in automation equipment, categorizing them into three classes. Then, what specific types exist, their basic characteristics, features, and applications were briefly introduced in this series. If you want to learn more, later we will cover specific motor types individually for detailed explanation. Not only their features, but also their model numbers, brand characteristics, parameters, selection process, and calculation methods, etc. will be covered to help you learn. Okay? Well, today, this introduction to common motor types in automation concludes here. I am Instructor Bill. See you in the next lesson.